Okay, we're going to do some sample problems with significant digits. So in these first few, you're asked to round the numbers to 3 significant digits. So in our first example, we have 3.337. So we want to round it to 3 significant digits, and because the 7 is greater than 5, the answer would be 3.34. The next one, rounding to 3 significant digits, we would have to go up to 38,600. Then we would have in this next one 0.667. And we're just using the rules of rounding that we just went over. And then the last one, we would have 0.00123. So all of these now have 3 significant digits. Notice the second one, these 2 zeros are not significant because there's no decimal place, there's no overbar. Likewise, these zeros here are not significant because they're considered to be leading zero. So the 1, 2, 3 are your significant figures. Now in the next one, you're asked to do this multiplication and then give your answer in 3 significant digits. So when you plug this into your calculator and then put it in 3 significant digits, you should get an answer of 171. When you do the division, your answer rounded to 3 significant digits will be 3.39. Now in this next problem, you're asked to do the division and give the answer in the correct significant figures. So basically you have to figure out what's the correct number of significant figures. So let's first do this division. And when we do the division, we get 2.098, and we have grams per milliliter. Okay. Well, from looking at our original problem, this 2.518 has 4 significant figures. 1.2 only has 2 significant figures. Remember our rules for multiplication or division, our answer goes with the least number of significant figures, which would be 2. So therefore, this answer would have to be rounded to 2.1 grams per milliliter to adhere to our rules of significant figures. Okay. Let's do a few more. So here, you're asked to give the number of significant digits. So in this first one, you actually have only 3 significant digits. The 7 significant, the 3, and the 0 because of that decimal place. The next one, you have 3 significant. There again because of the decimal place. And then the last one, all your numbers are between 1 and 9 inclusive, so you would have a total of 6 significant figures. And then these last 2 problems, you're asked to calculate the answer and then give the answer in the correct significant figures. So you can see I've written the answers down for you. And now we want to take these and figure out what's the correct significant figures. Well, here, the first one, we're adding. So remember, when you're adding or subtracting, you go with the least number of decimal places. So we have 1 decimal place, so then that means our answer would have to have 1 decimal place. And it's rounded because of the 9 behind the 2. The next one, we only can have 1 decimal place. So the question is, how are you going to get this 400 into one decimal place? Well, you would have to put it into scientific notation, which we're going to talk about right now in our PowerPoints. So if we switch back over to our PowerPoint, the next thing in your chapter that's covered is powers of 10, also known as scientific notation. They're the exact same thing, just different labels for the same thing. And basically, we use this for when we have very big numbers or very small numbers. And you're representing it in a powers of 10 notation. So you can see here, you're basically putting it in 10 raised to a certain power. And here again, for some reason, my PowerPoint left off the equal sign. Okay, so let's look at the rules that we're going to follow. This is just a table that gives you some examples of how you put the number into a power of 10 notation or a scientific notation. Let's look at the actual rules. So you're always going to write it as a number between 1 and 10 multiplied by a power of 10. That power of 10 is going to be positive for large numbers. It will be negative for small numbers. So this is what I mean. If you have the number 634 and you're asked to put it in scientific notation, power of 10 notation, you need that number 634 to be between the numbers of 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So to do that, you would put a decimal place right after the 6, and you're going to count the number of places you must move that decimal place. And when I move that decimal place, to get to my original number, I'm actually moving it 1, 2. So hence 6 times 10 to the 2. Now, the next example, I have 0.000634. Remember, my number can only be between 1 and 10. So if I were to put a decimal place right here, so I would have 6.34, I am moving my decimal place 1, 2, 3, 4 places. And because it's a small number, it will have a negative exponent. So basically, the power of 10 is just how many places you have moved the decimal place. Now, sometimes you're going to see a power of 10 just written as that number 10 raised to a power. Like in this case, 10 to the 5th. It basically means 1 times 10 to the 5th. Now, if you do not have an exponent, it's assumed to be 0. So 4 times 10 to the 0 is just 4. How are you going to put this in your calculator? This is super important how it goes into your calculator, because if you do not enter it in this exact manner, you're always going to be a decimal point off in terms of your answer. So you don't ever want to use the multiply key. These two buttons you should make sure your calculator has, the EE or EXP. You do not want to use the caret key on your calculator, because I've seen students get the wrong answer using it. So if I wanted to enter 5 times 10 to the 5th, I'm going to press 5, then I'm going to look for my EE or EXP button, and then I'm going to hit 5. And that is telling my calculator that is 5 times 10 to the 5th. Make sure you never hit that multiply key when you're inputting scientific notation. So in this little example, distance to the sun can be expressed in many ways. Okay, so all of these are basically the same answer, but the most correct one is this one. Okay, because that adheres to the scientific notation, power of 10 notation correctly. 93 right here is not between 1 and 10. 0.93 is not between 1 and 10. And this first one is correct, but it's a lot of zeros to write. So all of these are correct, they're just not the most correct format. So here we have, in this one, we have this multiplication, and we're going to go back a little bit, talk about scientific notation, just some more examples. You're asked to do this calculation and round to two significant figures. So this is your answer that you get. I need to round it to two significant figures. Remember, the leading zeros are not significant, so it's going to round to 0.0068. The 6 and the 8 are your two significant figures. Now, we can change it to scientific notation, which would be 6.8 times 10 to the minus 3, because I'm moving my decimal place 1, 2, 3. Small number, negative exponent. Okay. Here's another one. So we're going to do this division, and we get this answer. But you're asked to put it to two significant figures. So you need to round up to 30, okay? Because it's a decimal place, this 0 at the end is significant. These leading zeros are not significant. So these are my only two significant figures. And then to put it in scientific notation, I'm just going to count 1, 2, 3, 4. So that is 3 times 10 to the minus 4. And like I said, that trailing 0 is significant because of the decimal place there. Okay, let's do a little bit of scientific or power of 10 notation practice. So let me switch over to this other program. Okay. And you're going to be asked to write this in powers of 10 or scientific notation. So remember, we have to be between 1 and 9. So we would do 8.976 times 10, and we're moving that 1, 2, 3, 4 times 10 to the 4th. And the second one, we would have 7.07 times 10, and we're going to move that one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, small number to the negative 13. Now in these next two, you're asked to do these calculations and then put the answer into scientific notation. So when I do this calculation, my answer comes out to be 156.4. Now that is not in scientific notation, because remember, my number has to be between 1 and 10. So I can go 1.56 times 10, and I have moved that decimal place 1, 2, so 1.56 times 10 to the second. Okay, on this next one, I'm going to do the division, and I'm going to get my answer at 34, 1, 2, 3, 1, 2, 3, 4, and you're asked to put that in scientific notation, so that's going to be 3.4, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th. Now in this one, you're asked how many significant figures should be reported for the results of the following calculations. Okay, well let's see. In this first value, we have 4 significant figures. Because of this decimal place right there, the 3, the 1, 1, 0, all significant. This next one, we only have 2 significant figures because the leading zeros are not significant. So therefore, your answer must be in 2 significant figures. So when you plug these in your calculator, you're going to get 6.5, times 10 to the minus 3, which gives you 2 significant figures. Okay, this is all for this part, and we will come back in our next part and finish up chapter 1.